With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
According to question, a point charge q is moving in a circular orbit of radius capital R in xy plane with angular velocity omega. This can be considered as equivalent loop carrying steady current of q omega upon 2 pi. Uniform field, magnetic field along z axis is now switched on, which increases at a constant rate from 0 to b in 1 second. Okay, so we can consider that the rate of change of magnetic field means dB over dt is equal to b. Okay, because change in magnetic field in 1 second is b. So assume that radius of the orbit remain constant, so that is also given that the radius of the loop is remain constant. The application of magnetic field induced an EMF in the orbit, and the induced EMF is defined as work done by induced electric field. Okay, so that is the induced electric field in moving a unit positive charge around a closed loop. Okay, so when the magnetic field changes, there is a induced EMF in that loop, and due to that induced EMF or induced electric field will do work for moving a positive charge. Okay, so for orbiting charge, the magnetic dipole moment is proportional to angular momentum with proportionality constant lambda. Okay, so now we have to find the magnitude of induced electric field. Okay, we have to find induced electric field in orbit at any instant of time during the time interval of magnetic field change. Okay, so we have to find the induced electric field. So let's consider that is the xy plane. Okay, that is the x and the y, and in that xy plane, that is the loop, and the radius of loop is capital R. Okay, according to question, magnetic field is increasing in that region, and the direction of magnetic field in z direction means magnetic field is the out of the plane. Okay, which is increasing. Okay, magnetic field is increasing, and according to question, the rate of change is constant and changing 0 to b in 1 second, so we can say dB upon dt is equal to b. Okay, so induced electric field is equal to close integral E induced dot dl vector is equal to d phi over dt. Okay, d phi is the magnetic flux that is changing in that region. Okay, and dl is the element taken at that loop. Okay, so that is the dl. So, and the electric field. Okay, electric field is the tangential direction. So at each point, electric field uniform at that loop. Okay, at each point, because as we know that induced electric field is uh, in form of closed loop, so at each point of that loop electric field will be uniform. So we can say E into close integral dl vector is equal to d over dt. The flux is equal to ba, and the a is the area, so we can say magnetic field b, and the area pi capital R square. Okay, and the integration of dl, the element for complete loop, that will be equal to total length of the loop, that is 2 pi capital R, that is equal to pi R square, because according to question the radius of loop is constant, so R is constant, dB over dt. Okay, so we will get induced electric field E is equal to pi R square upon 2 pi R into dB over dt. Okay, so E is equal to R upon 2 dB upon dt, that is equal to b. Okay, so the final relation will be equal to b r by 2. That is the magnitude of induced electric field. So according to that, which option is correct? According to that, option B. Option B is correct.
For class 6 to 12, ITG and NEET level. Trusted by more than 5 crore students. Download Doubt and App today.